Welcome to our Mechatronics course project. We are from team number 1. Our project title is Autonomous Vacuum Cleaner with Mopping. Myself Amrut, my teammates are Sanket, Akash and Deepthi. So our problem statement is the main problem with vacuum cleaning, that is almost human interface is required to operate. It's an exhausting task for humans. So we thought of building a prototype which would be cost effective, economical and also durable. The main objectives are to provide multifunctional features such as cleaning the floor near difficult areas along with mopping, thereby reducing time consumption. Our main objective is to consume less than 20 watts of power, to build within a cost of Rs 3000, to provide clean mopping feature for a minimum of 20 to 30 minutes. The objectives or the functions is to dry clean the floor by vacuuming as well as cleaning the floor by roller brush. The goal is to design an omnidirectional platform with infrared sensors, ultrasonic sensors which will be used to detect objects and perform operations. A conventional machine absorbs dust in one direction, but our prototype will be able to rotate 90 degrees vacuum unit which will help in cleaning difficult to reach areas. Here is the block diagram of moving unit and cleaning unit. Next is the comparison of existing products and along with our prototype. As you can see, the power consumption is least of our design prototype comparing to all other design market prototypes. Suction power is considerably comparing all other prototypes, and the cost is much cheaper. This is the circuit diagram of our model prototype. It consists of 4 DC motors, 1 DC motor for suction, an ultrasonic sensor connected to servo and a battery along with transistors which are all controlled through Arduino Uno R3 along with L293 driver. Next is the V model representation. It consists of concept of operations, system requirements, subsystem requirements, implementation, computer science, electrical and mechanical subsections, and then verification validation is done. Next up is the concept selection. We proposed 4 concepts in which we finalized prototype 1 based on selection of concept. We have done selection of criteria, concept variants and different weightage given to selection criteria. The criteria include ease of use, manufacturability, duration of service, cost, safety. Based on that, you have selected concept 1 or concept A as our final variant. Next is comparison of different prototypes. It includes actuators used, sensors used and program and the type of application for different type of prototypes compared in the existing market. Some use a belt-driven system and some use ultrasonic sensor and some use C++ or Python. Next is the list of components used in our project. It is DC motor, ultrasonic sensor, Bluetooth module, 12 volt water pump, PC fan, 12 volt rechargeable battery, breadboard, Arduino Mega, TIP transistor, then comes servo motor and L293 driver. Next up is the motor sizing and power required. It includes the mass of prototype, that is 4.5 kg. Then comes power, which is required 16 watts, and hence based on these calculations we get approximately 60 rpm DC motors that we're gonna finalize for our course project.
A very warm welcome to one and all present. This is our build prototype, that's autonomous vacuum cleaner, which consists of 4 DC motors and L293 driver, which will be able to control the direction of DC motor, which will be connected to Arduino, in which program would be written, as well as a prototype consists of ultrasonic sensor and a servo motor. Ultrasonic sensor is used to detect the object. As soon as ultrasonic detects some object, the servo motor turns 180 degree to left and 180 degree to right. It detects again, and if no object found, it goes in that direction. It gives feedback to the L293 driver as well as Arduino as the feedback is given, and the wheels will rotate as the code is given. So next is the cleaning unit, which consists of water storage and a 12 volt pump which will be inside the water storage. As soon as water is filled, through the filler, the water will be pumped through the 12-volt pump which will be connected to the pipe. As soon as it sends the water through pipe, the water droplets will fall through this pipe which will be connected through the mop. It connects through the ground and the ground would be cleaned. So the next unit is vacuum unit, which consists of a storage unit and as well as suction unit, which will be able to suck the dust through this and which will be able to store the dust in this storage unit. And the storage unit will be connected through the DC motor of high RPM 1000 to 2000 RPM, which will be controlled through a switch, and the switch would be connected through the battery, and every other components is supplied through this battery.
So this is the integrated program for our prototype which consists of all the units. So as soon as we upload the program, the bot would work like this.
So this is a moving unit. As you can see that Arduino already the program would be uploaded. As soon as it senses some object, it moves back and again searches which direction it has to go. So this is another trial. So you can, as we on the switch, it goes forward. It senses some object there and it searches for another place to go, and it moves its tires a little bit backwards and changes the direction of the wheel. So this is the vacuum unit. So as you can see that there are few pieces of paper. What happens in vacuum unit is that, as I explained in the video previously, that the sucker unit sucks the paper. So as you can see that as it comes near to the paper, as you can see in the storage unit, that the paper would be collected inside it. So as soon as it sends something, it goes back and it again searches.
Next is the mopping unit. As you can see here, the bot cleans the floor with the help of mop and water. Here is the vacuum assembly 3D model. As you can see, there are many components as explained in the physical simulation. Here is the exploded view of our 3D model. So this is the vacuum unit, this is the moving unit, and this is the mopping unit. So when the bot moves forward, it detects for the obstacles. If there are any obstacles, it searches by turning it with the help of ultrasonic sensor. So as you can see here, the ultrasonic sensor detects for obstacles. If there aren't any, then it moves forward. And whenever there is a vertical wall, you can turn the mopping unit to 90 degrees to clean vertical walls also. So whenever there is again a vertical wall, even the mopping unit can be used to clean vertical walls as well as flat surfaces. Hey guys, this is the electrical simulation of our course project. It consists of 4 DC motors which are controlled with the help of L293 driver and Arduino Uno. It consists of 2 batteries which are connected to power these 4 DC motors. Here, as I start simulation, we can see that 2 motors are turning in clockwise direction while 2 other motors turn in anti-clockwise direction. Here is the electrical simulation of object detecting system. It consists of an ultrasonic sensor and a servo motor. So let's start the simulation. So as there is an object away from it, the servo turns 90 degrees. I'll bring obstacle in front of an ultrasonic sensor. The servo makes 180 degrees. Again, when I remove the obstacle, again the servo takes 90-degree turn. Lastly, we would like to thank Madhusudana sir for helping us throughout the project and successfully implementing the project.